Solids, Liquids, and Gases by Faith Johnson. What is matter? Matter can be described as being made up of atoms. This means matter can be anything around you. Atoms and molecules are compressed of matter. A gas is a state of matter without definite shape or volume. Gases have their own specific behavior depending on different variables such as temperature, pressure, and volume. In gas, molecules flow easily while moving past one another fastly. Gases assume the shape and volume of its container. Molecules move past each other because they are well separated with no regular arrangement. They vibrate while moving freely at high speed. An example of gas is helium. Helium is what's inserted into balloons to make them float. Liquids are also a state of matter. Liquids have a definite volume but no fixed shape. Liquids are not easily compressible and have very little space between molecules, but flows freely. In a jar, liquids will take up the shape of its container as much as it occupies. Molecules in a liquid are close together with no regular arrangement. Liquids also vibrate and slide past each other, but not as freely as gases do. The attraction to each other creates the vibration. Like gases and liquids, solids are also states of matter. In solids, particles are compressed together, meaning that molecules cannot move past each other freely. Solids have a fixed volume and shape. In solids, molecules are tightly packed and usually in a regular pattern, which is rigid. The molecules' attraction to each other allows them to be compressed together, making them vibrate. You might ask yourself, why would I care what temperature water boils at? You can refer to your amazing children's book on page 12 while looking at the amazing illustrations by yours truly. You can see elbow noodles starting to boil. To help your chef not to overcook the pasta, you would say, boil the water at 212 degrees Fahrenheit. This type of diagram shows conditions like pressure, temperature, and volume at which distinct phases occur at equilibrium. The diagram is divided into three areas which represent solid, liquids, and gases of a substance. So when a solid is heated at a constant temperature, it melts into a liquid which eventually boils to form a gas. This is called a phase diagram. When reading a phase diagram, there are three distinct curves that are very important. Each line represents the state of temperature and pressure which the different phases can occur at equilibrium. The point where it says normal boiling point, this is also called the ATM. From line A to D, this represents the border for liquids and gases. This process from a liquid to a gas is vaporization. But from a gas to a liquid, this is called condensation. From line A to C, this represents the border of solids and liquids. Changing from a solid to a liquid is called melting, and from a liquid to a solid, this is called freezing. The labels on a phase diagram include triple point, critical point, pressure, and temperature. Again, you might ask me, Faith, why do I need to understand a solubility diagram? I would say, well, if you didn't know how to read a solubility diagram, how would you know how much sugar or Kool-Aid to add to water so it dissolves properly? Solubility curves shows the amount of solute that can be dissolved in water in a particular temperature. Solubility diagrams are used to determine the amount of solute it takes to dissolve 100 grams of water at any given temperature. Solubility curves are graphic representations of changing temperature of solubility at any given substance and solvent. So back to our analogy of sugar, Kool-Aid mix, and water. The Kool-Aid sugar will be our solute and the water will be our solvent. The key concept in answering a test question on your final exam is knowing how to read a graph properly. A solubility curve will show a curved line that represents the point of a temperature and solute that is saturated solution. That means any point on the line solution is considered saturated. On the bottom, the x-axis, you would have temperature, and on the side, y-axis, you would have the solute. The goal is to read the graph and answer the desired questions pertaining to the diagram. Anything below the curve is unsaturated. Anything above the line is supersaturated. The labels on the diagram are saturated, supersaturated, and unsaturated. I hope this presentation helps you understand phase diagrams and solubility curves.